Okay, I started the recording once again. So no issues. So I was telling you what? Okay. The user-defined data type typecasting, right? So this is an example. So you have an animal class and you have the dog class, right? So there is a relationship between the dog and the animal. You use extends keyword, right? If you want to make a relationship. So this is the way you can create an object, and this is also a way to create an object. So we will understand this way of creating an object. So keeping the reference of keeping the object of the child class to the parent reference, right? So there are so many advantages when you do the object creation like this, and you can see what benefits that you are going to get out of this, right? So this is just a kind of an idea. I have just given you the idea. How we can implement that idea, we will understand in a short period of time. Okay? Now I can say that the process of converting the theory is going to be same. You can say that the process of converting data from one user data type from one user data type to another user data type. One user defined data type, I can say. One user defined data type to another user defined data type. Another user defined data type is called as user defined data type casting or class level type casting. Class level type casting. Right? So again, it is categorized into two ways. They are classified into two types. So one is what I let me remove this. So one is you have the upcasting. Second one is you have the downcasting. Upcasting and the downcasting. So what is the difference between these two typecasting? So when I say upcasting, so what we are going to do with this upcasting? When I say downcasting, what we are supposed to do? What are the benefits that you are going to get from this type of typecasting? Let me start with the upcasting. Okay? Upcasting is something like very simple. Okay, upcasting is a type. The type of typecasting in which a child object is typecasted to the parent class object. Okay, so let us understand this in the diagrammatical way. See, just imagine, guys, we have two classes. Okay, I am taking two classes in the form of this. Increase in brightness. I am taking two classes. So one is I have a parent class. Okay, just imagine that I have a parent class, and I have also a child class. I have one child class. So this is my child class and this is my parent class. Right? If we want to make a relation between the parent and the child, we know this already. We are going to use an extends keyword. Only with the arrow mark, we can say that okay, the class that is being pointed to is called as the parent class, and the class that is from where the pointing is happening, that is called as what? Child class. I can say that because of this extends keyword, there is a relationship happening between these two classes. Right? We have been discussing about these things for a long time. Okay, now you see, if you want to convert, okay, if you want to perform the upcasting, so I can perform one thing. Okay, I can perform the casting in two ways. One is what? When you just place the object of the child class with the parent class reference variable. Okay, this process is called as what? This process is called as upcasting. Okay. This process is called as what? Upcasting. Okay, and when you create an object for the parent, and if you are trying to use the reference variable of the child, okay, this process is called as what? Downcasting. Okay, you call this as downcasting. Examples, you can have the more visualization in this way. Like when I say parent OP equal to new child, Let's say parent p equal to new child. Okay. Object is being created for the child class, but the parent reference variable is holding the child class object. This process is called as upcasting. So what is downcasting? The downcasting, you create an object, you use the child reference variable and you create an object for the parent class. Okay, this is called as what? This is called as downcasting. But the ideally in Java, the downcasting is not possible. We will understand why it is not possible in Java. Before understanding this, we have to understand the process of upcasting. Right? Simply, I can put it like this is what I was trying to say. This is what I was saying. This is a type of typecasting where the one primitive data type, which the child object is typecasted to the parent class object. So this is what I was saying. Right? So practically, how you can understand this? What are the advantages of the upcasting? Right? Let us say that I have a mobile guys. Okay. Let us say that I have a class called the name of the class is the mobile class. I'm going to take one method in my mobile class. The name of the method is going to be, so every mobile is going to have a feature called what? The calling feature, right? Calling feature. I have taken a simple method. Okay. The name of the method is calling. And I am also keeping a statement inside this method. The statement says, calling from mobile. Calling from mobile. Okay. Clear. Simple and clear, right? So I also want to take another class. Okay, the name of the class is the iPhone class. Class iPhone. Okay. My iPhone class is extending to mobile class. Extends to mobile class. I can also say that every iPhone is a mobile. I can say this way, right? Every iPhone is a mobile, right? Every iPhone is a mobile. So there is an easy relationship between these two things. Always remember, you make a relationship between two classes only when there is a kind of similar variables or similar behaviors. In this case, iPhone, okay, and there can be some methods inside the iPhone which would be similar to the methods that are there in the mobile phone. If you identify, okay, if you want to use some of the business logic in the from the parent method, right? And if you want to keep the specific logic in the child class method, right? There you make a relationship. There you exactly make a relationship. This is one of the examples for that. I can here I am taking something like I am also taking something like void calling method, right? The same method I am taking. The method is going to be same. And inside this, I'm going to keep a simple statement like system dot out dot println, okay, calling from iPhone. I'm saying calling from iPhone, right? So now perfect. Now I am able to create two classes. Okay. Now what are the options that I have? Let me say that I have also a main method. Okay, I have also a main method. Let me take a main method over here. Public static void main. Okay, just assume that there is string array arguments and there are some instructions. Simply I'm taking a main method inside the iPhone. Here the takeaway is I have an option, right? I have an option like I can create objects in two ways. Okay, mobile m equal to new mobile. Okay, so this is one of the ways that the object can be created. Right? So if you look at this, the reference variable is parent type, right? So the reference variable that you're using is the parent type, and the object is created for the parent type. I can also use another way like okay, iPhone. Let me say I equal to new iPhone. New iPhone. Okay, and if you look into this, the reference variable is of the iPhone type, and the object is created for the iPhone type. Okay, iPhone. Okay, so these are self-explanatory. Now with the help of reference variable with the help of reference variable I am able to call what? I'm able to call all the methods or all the properties that are there inside the parent class. So I can call the calling method with the help of the reference variable, right? So I can say that this business logic will be printed, right? And likewise, if I keep, if I use the reference variable I, but if I call the calling method, right? Okay. So I is of what type? I is of the iPhone type, right? So inside the iPhone, it will try to find is there any calling method inside the iPhone? Yes, there is a calling method. Okay, this business logic will get invoked, right? So this will be displayed on the console. So calling from iPhone will be displayed on the console, right? Now the third one I was telling you, right? What if I try to do like this? Okay, let us say that okay, I have this iPhone I equal new iPhone, right? So what I want to do, I want to type, the typecast operator. So this is the typecast operator. You know this. When I keep the opening and the closing simple brackets, right? When two simple brackets are enclosed, right? So we call this as what? Cast operator, typecast operator. Okay? What I'm trying to do, I'm going to use this reference variable I. Okay? I'm going to use this reference variable I, okay, which is getting typecasted. Okay? Let me remove this. I can say something. Okay? Uh, I am going to use a reference variable I, which is being typecasted to mobile. Okay? I'm assigning this to the parent class reference variable, which is what? Which is M. I'm taking it as M. So this process is called as what? Upcasting. If you look at one thing, right? So this is upcasting. So why this is upcasting? I am converting. Okay. Just let us come to this once again. So this is the reference variable I, right? I is of what type? I is of iPhone type. Okay. This I reference variable I'm using it, right? I am typecasting this reference variable to mobile type. So a conversion is happening. Okay. Conversion is happening to mobile type. It is getting converted to mobile type, right? After the conversion, so you have converted this to mobile type. So it is your responsibility to assign it to the mobile type itself. This process is called as what? Typecasting. This process is called as what? Typecasting. What kind of typecasting is this? Is called as what? Upcasting. Why upcasting? You are using the what we call it as the iPhone object. You are placing the iPhone object, or you are assigning the iPhone object to its parent class object, mobile object. You are assigning the iPhone object to this mobile object. So this process is same as, okay. You can imagine like this, or else you can do what? You can also do it in this way. It is also same like this line is same as mobile m1 equal to mobile. Okay. What is the value inside I? What is the value that is assigned to I? New iPhone, right? New iPhone. Okay. So this is same as this. This is same as this, right? And also this is also same as what? This is also same as, if you are doing the if you are using the typecast operator for the upcasting, this is optional. Okay, this thing is optional. This is completely optional. You can remove that, and you can also do it like this. Mobile m1 equal to new iPhone. Okay, so this is same as this. Okay, either you can use this. This is also called as upcasting. This is also called as upcasting. It is also called as upcasting. But everywhere you would see this is how you are going to use the upcasting. And if you just look at this, okay, the idea behind this line is very simple. You are using the child class object. Okay, so the right hand side is the child class object, iPhone object. Object is created for the iPhone, but you are assigning this iPhone object to its parent class reference variable, which is what? Which is mobile. This mobile, right? So previously you are able to create mobile reference and mobile object, iPhone reference and iPhone object, but here is like parent reference but child class object. This process is called as what? Upcasting. Either you can use this rule, you can go by this syntax, or you can go by this syntax, or you can go by this syntax. So the reason why I'm showing this all these things is how you're trying to convert it from the lower data type to the higher data type, or the child type to the parent type. Okay, the question is, what are the advantages? What are the advantages of? What are the advantages that we have when you use this kind of situation? To understand this, let me write a small program. Let me introduce a small, Java program. Right? Let me remove. Let me use a plain brush itself. No issues. Okay. So imagine that I have class like. Let me say I have class the animal class. So what are the behaviors that the animal can have? Animal, they usually, they eat, right? Animal, they usually eat. Okay, what is other behavior that animal can have? Animal can make noise. So animal can eat, animal can make noise. Okay. So I have what? I have two behaviors inside the animal class. So let me take let me add something here. Okay, system.out.println. I want to add what? I want to add animal is eating. Right. Second one is system.out.println. Okay. Animal makes noise. Animal makes. Okay. So two behaviors I have in the animal class. Okay. Let me take another class. So I am going to take the another class here. Class. This is the dog class. Okay. So what are the behaviors that I can add inside the dog class? So behaviors can be like, even dog makes noise. Right? Dog makes noise, but okay, how it is going to say, I mean, the noise is going to be in the form of bow bow. Right? And another quality that the dog can have is void action. Okay, what kind of action that the dog typically have? Age waging tail. Right? Let us take these two things as an example. So now, if you see, there is no relationship between these two classes. Right? You have the dog class and you have the animal class. You are not making any relationship. Right? So once when you start making a relationship, you are supposed to use what? You are supposed to use the extends keyword. Right? So the extends keyword will ensure that a relationship happening between two classes. Friends, animal. Okay, a relationship is happening between two classes. So dog is extending animal. I can say that every dog is an animal. Okay, now the when you give this code to the piece of code to the compiler will check. Okay, don't you think that? So you have the make noise method. Okay, name of the method is make noise method. That is there in the animal class, as well as the make noise method is also there in the dog class. So there are two identical methods. Right? The moment you start using the extends keyword, so the name of the method is make noise here. The name of the method is make noise here. Right? So you are like you are trying to use the same method name in the child class. Right? So this method will be, technically this method will be called as the override method. Override override method. So again, we will come to this override concepts in the polymorphism. So this is not the actual topic of polymorphism, but these are some technical jargons. So since you are using the same method name, the parent class as well as child class, the method that is there inside the child class is called as override method. The method that is there in the parent class is called as what? Overridden method. Right? So this looks a bit clear, right? We have these two things. Right? Now the question is, let us say that I have a main method inside the dog class itself, or let me take a separate main method. Usually what we do, we can create an object of what? Animal a equal to new animal. Okay. So with the help of animal reference variable a dot, okay, I can name animal. So this a is of what type? Animal type, right? I can able to call the eat method. When I call the eat method, we know what method will be invoked, right? You see, animal is eating will be displayed in the console. Animal is eating, right? And when you say a dot make noise, okay, again animal makes noise will be displayed on the console. Animal makes noise will be displayed on the console. So this is a very straightforward, right? Likewise, when you create an object for the dog, dog d equal to new dog, right? So with the help of the d reference variable, right, d is of the dog type. So what are the methods that you can call by using the, how many methods you can call by using the d reference variable? I can say that, sir, you can call the make noise method. You can call the make noise method. You can also call the action method. You can also call the eat method. You have three methods. Why three methods? Because this is the child class. Dog is the child class. With the help of the child class, you are okay to call the make noise method. But always remember, right? When you call make noise method, the control will always try to call the method that is there. And first, it will check for this make noise method in the current class. What do you mean by the current class? So I'm calling this make noise method on top of the variable d, right? So d is of what type? D is of dog type, right? D is of dog type. So make noise method will be looked inside what? Inside the dog class. So it has found the make noise method. So this will be called. Bow bow will be the answer. What will be the answer? Bow bow will be displayed on the console. And also you also have an option to d dot, you can call the action method, right? Action method is part of the dog class itself, right? Output is going to be what? Waging tails. Right? And what is the next one? Okay, by using this reference variable, you have an option to call the parent class behavior. But you cannot call this method. You cannot call this method because this method is overridden by the child class. It is just like, okay, if you don't like any parent class implementation, if you don't like any parent class implementation, let us say that in the parent class you have the method like make noise method, right? This method has some other implementation which is not relevant to the child class. So the child class, you have an option to override this method so that the make noise method, name of the method, if you keep the name of the method same as the name which is there inside the parent class, right? You call that as what? The override method. So the call always refer the method call will always refer this. You don't like this implementation, that's why you are calling, you have you have used the override concept so that the child class method will get priority, right? And also with the help of the d reference variable, you can also call the eat method. And if you see, the eat method is not part of the dog class, right? So d is of dog type. So the control will try to search for the eat method inside the current class, which is dog class. Since it is not able to find it here, it makes use of this extends keyword and it will jump to the parent class, which is animal. In there it will try to find the eat method. Since it is already there, now you are able to call what? You are able to see animal is eating in the console. Okay. Now with these two things, I can able to conclude. I can able to make one observation. What is that observation that here I can make? When you create an object for the animal class, and if you keep the use the animal reference variable, you can call all the methods that are there inside the animal class. Only two methods are here, right? You are able to call all the methods that are present only in the animal class. But when you create an object for the the what we call it as the child class, right? You can able to call all the methods that are in the child class, as well as you can able to call all the methods that are in the parent class. And if you don't like the parent class implementation, you can override that and you can use this. Right? Totally, you are able to call three methods. One method is already overridden, so you are able to call three methods. So in the parent class, you are able to call only the parent methods. In the child class, you have an option to call the child methods as well as the parent class methods. And if you don't like any implementation in the parent class method, you're going for this override concept. Okay. Now, what would happen when you create an object for the by using what would happen when you try to do the upcasting? What is upcasting? Taking the parent reference variable A and creating an object for the child class history. Right? So with the help of this reference variable, remember one thing, with the help of this reference variable, you can call all the methods that are there in the parent class. First remember, you can call all the methods that are at the parent class. Second one, you cannot call child methods. You cannot call child methods, but if any of the child method overrides parent method, that will be, I will tell you what is this. Okay. Now let us say, what if I try to, by using the animal class reference, A is of animal type, right? So clearly A says that A is of what type? Animal type, right? With the help of a reference variable, okay, what if I try to call something like action, right? This is that's an action. Okay? Action. You will get a compilation error. You cannot call the specific child class method. Action is where? Where is this action? Action is not there in the parent class, right? In the parent class, you have eat method, you have make noise method. Action is not part of the parent class method. Action is a part of the child class method. You cannot call this. You cannot call this. But now the magic happens when you say a dot. Okay, when you say make noise, Okay. Now make noise method is there. Make noise method is there inside the parent class. Parent animal class is a make noise method, right? And this method is overridden already. This method is overridden already. This method is overridden by whom? By the child class make noise method. Okay. Now the call will go to, okay, it will check, the control will be traveling to the, control will be traversing to the class A to check for make noise method. Of course, it has found the make noise method, but it has also found that it is an overridden method, which means this business logic has been overridden or has been changed by the child class method. So the child, it will invoke the child class method. It will invoke what? It will invoke the child. This is an advantage. This is an advantage. It will see, okay, make noise method is there inside the animal class, right? It will also check, is there any make noise method in the child class? Of course, there is a make noise method. And this method will be invoked. The resultant value is going to be what? How will be called. Okay, and with the help of what? With the help of a dot eat, okay, with the help of this reference variable, if you call a dot eat, eat is part of the parent class, right? It was part of, so this will be called animal is eating. Animal is. So with the help of this reference variable, you are placing a restriction to call all the specific methods of the child class. What are the specific methods of the child class? Action is the specific method of the child class. You are placing some restriction to call the specific methods of the child class. You cannot call the action method. You cannot call the specific method of the child class, but you can call the overridden methods of the child class, or the generalized methods of the parent class. You can call generalized methods of the parent class, right, or the common methods of the parent class. Okay? You cannot call, you can't call specific methods of the child class, right? What methods you can call? Only the methods are overridden. Only if the methods are overridden, you can call them. You are placing some restrictions, okay? So when you create an object like this, you are directly placing some restriction that specific methods are not allowed to be called. Only the overridden methods are allowed to be called. Only the common methods are allowed to be called. So this is an advantages of what? These advantages can be visually seen when we start building the Java project. Till now, you will find it as a disadvantage. It is not a disadvantage. This is an additional advantage. I will give you one more example, right? One more example could be like this. Okay, let us say that I have three classes. One is what? One is animal class. Okay, in my animal class, let us say that I have a simple method, right? Let me say I have M1 method. Okay, I have M2 method. Okay, and I have M3 method. Okay. There are three methods inside the animal class, right? And let us say I have the cat class. Okay, let us say I have the dog class. Now focus here. This class is also extending to animal. Class extends animal. This dog is also extending to animal. Yes. Right? How is the relationship here? There is a parent class, okay, which is an animal class. Okay, there are child classes. One child class is the cat class, and second child class is what? The dog class. Okay, now there is a relationship. So there are two children for one parent. This is possible. This is called as what? Hierarchical inheritance. Now you see, okay, let us say that I have the method like I have doing something like M2. Let us say that there is an M2 method in the cat class. Okay. Let us say that there is M4 method in this cat class. Let us say that there is M3 method inside the dog class, and there is M5 method inside the dog class. Okay. Now you tell me, this is just a kind of assumption. Let us try to understand. Okay, when I give this piece of code to you, always find the relationship. Okay, the cat is making a relationship with animal. Okay, always find the identical method. So M2 is identical. This M2 is identical and this M2 is identical. So this M2 method is overridden, right? I can say that the M2 method of cat class is overridden the M2 method of what? The animal class. So these both methods are what? Overridden. Right? Now when I create an object like this, right? When I do upcasting like this, animal, okay, A equal to new cat. With the help of a reference variable, now you tell me, okay, you tell me the answer. With the help of a reference variable, if I call, M1, can I call M1 with the help of a reference variable? Anyone?
Yes, sir.
I can call M1 because A is of what type? Animal type, right? M1 method is part of animal class. No issues, I can call this directly. Okay. Can I call M3?
Yes, sir.
M3 can also be called because it's also part of class. Okay. When I call M2, which M2 method will be executed?
Element.
No. Yeah, when I call M2, this is where you have to focus. When I call M2, now the priority will be given, okay? The child class M2 method will be executed. Always from this is the advantage of what? This advantage of the upcasting. So both the method names are same. The priority will be given to the child class M2 method. This is the takeaway, right? And when I say something like when I say a dot M4, is it possible or not possible? Just tell me. A dot M4.
Not possible.
It is not possible because A is of what type? A is of animal type. Only you can call the generalized method of animals. Okay, this is the generalized method. M1 is the generalized method. M3 is the generalized method. Only you can call. Okay, and since M2 is also part of animal, but it is also available in the child class. So this will be given priority. Common methods of the child class you cannot invoke or you cannot call the common methods of the child class. There is a restriction, right? You are placing some restriction. You're saying that I do not want to call, I should not allow to call any common methods of the child class. You want to place such restrictions, you will go by this. So this is just a generic idea. Just a generic idea. Right? Likewise, now you answer me. I have an option. See, now let us go by this. If you see, when I create an object for animal equal to animal, let's say animal B equal to new dot. Okay, animal B equal to new dot. So what is happening? Okay, so this is the animal. The relationship is there between animal and the dog, right? Identify the common methods. So these two are the common methods, right? Overridden methods. I can say these two are the overridden methods. Both are the same method name, right? Overridden. So with the help of the upcasting reference variable, with the help of B reference variable, can I call M5?
No.
M5 can't call because it is specific. It is specific method of call because B is of what type? Animal type. You are allowed to call all the methods of animal type. You have the freedom to call all the methods of animal type. Always you have freedom to call all the methods of animal type, right? However, when the animal class has any of its method overridden, for example, if I try to call something like M3, right? So M3 is part of animal as well as it is part of parent as well as it is part of child. Now the child method will get priority. This method will be invoked, right? M5 will never be called. You cannot call this M5 method. So this is a restriction that you are placing with the help of what? With the help of upcasting. So it is just like if you want to understand this, there are a lot of advantages that you can understand with this. When you are developing project, I will give you one more analogy. The one more analogy would be like, for example, okay, let us say that you are borrowing a vehicle, right? So let us say that you are approaching the transportation services and you just want to borrow the vehicle. Okay, what do you want to? You just want to drive from one location to another location. You are not worried about what type of the vehicle is. Okay, it can be a lorry, can be a car, can be something like the truck. It can be what? It can be also something like an auto, or it can be bike also. Whatever it is, you're not worried about. You just want to borrow the vehicle. Just want to borrow vehicle. Okay, but the vehicle method can have the common behaviors like you can start the vehicle and you can drive the vehicle and you can stop the vehicle. You can do these three things with the vehicle. Okay, you're not worried about whether it is a lorry or car. But if you see the special behavior, right? Special behavior of lorry can carry loads, right? Special behavior carry loads. And inside the car, the special behavior can be you can turn on AC. Turn on AC. But you don't expect these things when you are approaching the transportation services. When you say truck, okay, it can also carry heavy loads. Heavy loads. Don't worry about that. When you say auto, okay, you are like you can also what with the special behavior, like some kind of special behavior in the auto would be like you can drive freely, or else you can say mileage is more, bit more. Specific behavior, more mileage. When you say bike, even more mileage, even more. These are specific. But you are not worried when you do not have to worry about the specific behaviors. You don't worry about the car load, I mean the road thing. Don't worry about the AC. You don't worry about these mileage. You don't worry about all this stuff, right? You don't worry about all these things, right? You always worry about what? You always worry about how to start a vehicle, how to drive, and how to stop. Moving from one location to another location. So that is what your actual worrying is about. Is okay. This is the analogy. This is the analogy, right? So by using the, if you create an object, for example, when you say vehicle B equal to, you can say vehicle B equal to new lorry, right? So there are restrictions to this method. You're not worried about this. You're worried about only this. Likewise, when you say something like a car C equal to, not car, vehicle C equal to new car, right? You are, since you're not worried about this, restriction is that you don't want this. You are not worried about this turn on IC. Okay. Only you are worried about what? Start, drive, and stop. Able to follow, are able to understand analogy. These are the restrictions, okay? These are the restrictions placed. These are the restrictions placed on a specific behaviors. All you worried about is these are restrictions placed on the common behaviors or the specific behaviors. All you worried about the generalized behavior. Generalized behavior. If that is the case, you are going for what? Upcasting. Upcasting. Right? So making class, so I can say that the vehicle class is the parent class. So all these classes are the subclasses. All these classes are the child classes, and you are creating an object for the child class, but using the parent class reference variable, so that the common methods are blocked and the specific methods are given. Right? So this is what about the upcasting, and there is a concept, guys, in the future, not in the future, after completing downcasting. So we are going to cover the polymorphism. Okay, over there we will try to, these things will be understood much better. Okay? So our knowledge is not sufficient to get the complete knowledge about upcasting in the current topic, but in the polymorphism topic, these things will be understood clear, because we are not pretty sure about the overriding and what is the overriding is actually. After getting the complete picture of the overriding, then things will make more sense, right? And also in the interface concepts, okay, there is a concept of interfaces and abstract classes. Interfaces and abstraction topic is there. Over there also we'll understand the complete utilization of this, the upcasting. Till that, show some patience, right? Try to practice this. This will work in the laptop. Okay, I did not show these things practically. You can just try to practice it from your side. If you come across any doubts, you can ask me. We'll continue tomorrow.